All right, everybody. Today we're going to be doing the practice and problem solving for lesson 7-4, use probability models. Number 7 says, Murray spins the pointer of the spinner shown at the right. What is the sample space for the probability model? Well, one might look at these and think, well, I'm just going to count the number of pies, which would be 1, 2, 3, 4, 5, 6, 7, 8. So it must be 8. But let's look closely. We see the probability model is really going to be all the possible things that can happen. Look, there's 2 A's, 2 5's, 2 3, and 2 Y's, which means it could either land on A, Y, 3, or 5. So our probability model will be A, Y, 3, or 5. What is the probability of each event in the sample space? Well, since there are 4 different things that can occur, the probability of all outcomes is 2 out of 8, right? 2 things out of 8. Or if we reduce it, they are both divisible by 2, the numerator and denominator, which would make 1/4. And like I said, that's a 1 out of 4 chance. Number 8 says Raphael spins the pointer of 2 spinners shown at the right. Find the probability of each possible outcome. Well, let's see. Of each possible outcome, remember it says Raphael spins a pointer of the 2 spinners shown at the right. Well, at spinner number 1, it can land on, let's see, spinners on the left, right? And then this is the spinner on the right. The spinner on the left could be 1 or 2, right? And on the first one, it was 2. So let's see, that means the next one could be 1, 2, or 3, right? So the spinner on the left, if it is 1, it can go ahead and be 2, 3, or 4. And the spinner on the left, if it's 2, could be 3, 4, or 5. Now, why are they saying 2, 3, or 4 when there's not a 4 over here? Let's look at this carefully. Remember, it says Raphael spins the pointer of the 2 spinners shown at the right. Find the probability of each possible sum. The sum is the key word here. So we could have spinner number 1 spin a 1. And then if spinner 2 gets a 1, the sum would be 2. If spinner 2 gets a 2, then 1 plus 2 is 3. And if spinner 3 ends up, or spinner 2 ends up being a 3, then that would be 3 plus 1, which would be 4. Now let's look at the spinner on the left going on 2. This would be 2 plus 1 if spinner number 2, or the spinner on the right should land on 1. And 2 and 1 would be 3. If it landed on 2, then this would be 2 plus 2, which is 4. And if it landed on 3, that would be 2 plus 4. 2 plus 3, which would be 5. Okay, so the probability of the sum being on 2, well, there's a 1, right? There's only 1 chance out of 6. And it landing on 3, the sum being 3, is 2 chances out of 6, which is 1/3. Of it landing on 4 would also be 2 chances out of 6, which would also be 1/3. And if it landing on 5 would only be 1 chance out of 6, which would be 1/6. Next for number 9, it says, be precise. An art and craft store has a crate that contains glass, wood, and brass beads. The front take turns choosing a bead without looking, recording the bead type, and returning the bead to the crate. The table shows the result of 300 selections. So they're saying that if we add all these up, it's going to come up to 300. Write a probability model for choosing a bead. Well, the probability of it landing on glass is going to be 60 out of 300. Wood would be 96 out of 300. And brass would be 144 out of 300. Of course, we've got to reduce each of these. 60 out of 300 would equal 20%, which means 60 divided by 300 would be 0.2, and we move that decimal over to be 20. 96 out of 300 would end up being 0.32, and then we would move it over twice and it'd be 32%. And then the probability of being brass is 144 out of 300. That would be 0.48. And when we move that decimal over twice, it would be 48%. Now, based on the frequency in the table, estimate the number of each type of bead that will be chosen if the friends select a total of 450 beads from the crate. Well, about 90 glass beads, about 144 wood beads, and about 216 brass beads. Now, remember, all we're doing is taking this 450, cross-multiplying it to the number that's there. I'm going to see if, once again, I can bring up the, nope, and once again, just like in the last video, it's not letting me have the pen option to write this out, but if I did, I would be taking, in the glass case, it would be 60 times 450 divided by 300. And the wood, on the wood one, the wood bead would be 96 times 450 divided by 300, and that would give them 144. And then you would take 144 times 450 and divide it by 300, and that would give us 216. All right. Let's see. Number 10, a bag contains 14 green, 12 orange, and 9 purple tennis balls. It says, create a probability model for choosing a tennis ball from the bag. Does it say a color? Let's see. The bag contains 14 green, 12 orange, and 19 purple tennis ball. Create a probability model for choosing a tennis ball. Well, all of them are tennis balls, so that's 100% chance, I would say, right? The sample space, they're wanting you to put what they would be for each of them, choosing a tennis ball from the bag. What they should have said was each type of ball. So let's see. We've got the sample space would be 14 green balls, 12 orange balls, and 19 purple balls. That would be 14 out of 45 for the green balls. That would be 12 out of 45 for the orange balls and 19 out of 45 for the purple balls. Now, suppose a tennis ball is randomly selected and then replaced 75 times. How many orange tennis balls do you expect? Oh boy, so we're changing the number from 45 to 75. So again, we're going to take the numerator, multiply it to our new denominator, 75, and then we're going to divide it by the old denominator, which is 45. So this is, in this case, for green balls, it would be 14 times 75 divided by 45. For the orange ones, it would be 12 times 75 divided by 45. And for the purple balls, it would be 19 times 75 and divided by 45. In the case, there would be 20. It would be 12 out of 45 for orange. It says, how many orange tennis balls do you expect? 20 of them, because we had 12 out of 45. Remember, we're going to take 12 times 75 and divide it by 45. That would give us 20. We use proportional reasoning to predict how many orange balls will be selected in 75 trials. There we go. 12 times 75 has to be equal to 45x. That means we would, we're going to take 12 times 75, then divide it by 45 to find out what x is, and that would be 20. Whew. Next, number 11 says, given that the probability of red peppers equals 3 out of 5, write another probability statement that to complete the probability model of a random pepper selection from the box below. Well, the probability of getting a yellow pepper is going to be 2 out of 5. Well, let's count how many peppers there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Out of the 15 peppers, there are 1, 2, 3, 4, 5, 6 that are yellow. So we have 6 out of 15. Both of those are divisible by 3. 6 divided by 3 is 2, and 15 divided by 3 is 5. That's where they get 2 out of 5. And then it says, high order thinking. A survey asked 600 people for their favorite genre of book. The table shows the number of people who preferred 4 possible genres. They got adventure, comedy, mystery, and romance. How many people surveyed responded with a genre that is not listed in the table? Well, remember they said there were 600 people. We have to add up all these, and if I do, I see that there is 132. Let's see, plus 150 will give me 282. Now we have 282 plus 102. Well, 282 plus 102 would be 384. And 384 plus 90, well, 384 plus 90 is going to give us 384 plus 90. 384 plus 90 is 472, I believe. And now we have to subtract that from 600. That's going to give us 126 people that did not pick any of those genres. So the answer is 126 people. You add up the total, and then you subtract it from the number of people asked. So find the probabilities and complete a probability model to describe each response, including other genres. Well, this would be 90 out of 600. This would be 102 out of 600. This would be 150 out of 600. And this would be 132 out of 600. And let's not forget, others would be 126 out of 300. So when we go ahead and we take 90 and divide it by 600, we get 0.15, which is 15% for adventure. When we take 102 and divide it by 600, that would be 0.17, which is 17% for comedy. Mystery would get 150 divided by 600, which would be 0.25. That means 25% of the people like mystery. And then we have 132 divided by 600, which will give us 0.22, and that is 22%, which like romance. Lastly, we have 126 people that didn't like any of these genres of books, and 126 divided by 600 would be 0.21, which would mean 21% of other people do not like any of these genres. Next it says 100 people buying gumballs from the gumball machine. 45 of them get a red gumball, 40 get a blue gumball, and 15 get a yellow gumball. Develop a probability model to predict the color of the next gumball purchase. Compare the probability of getting a red gumball to the probability of getting a yellow gumball. Well, remember, we said 45 of them get a red gumball, and 40 get a blue gumball, and 15 get a yellow one. So when they ask, compare the probability of getting a red gumball to getting a yellow one. Well, the probability of getting a red gumball would be 45, right, out of the total amount, and this would be 15 would be yellow. What is the total amount? Well, 45 plus 40 is 85, and 85 plus 15 will be, well, 100. So that means we got 45 out of 100 chance. I believe that's going to end up giving us about, I'm going to say I want to say a 9. Yeah, let's see here. 45 out of 100 would be red, blue would be 40 out of 100, and yellow would be 15 out of 100. The probability of getting a red gumball is 3 times as great as the probability of getting a yellow gumball. Why is that? Because 45 over 100 is going to give me a point. Let's see, we got to divide both of those by 5. That'd be 9. So a 9 out of 20 chance would be for a red gumball. A yellow one is 15. If we divide 15 over 100 by 5, the numerator and the denominator by 5, that's going to be 3 out of 20. So remember, 9 is 3 times as much as 3. And that's why we would get 3 times as many red ones as we would yellow ones. Part B, of the next 10 people to buy gumballs, 7 get yellow, 1 get red, and 2 get blue. Explain a possible reason for this outcome. Now remember, it says of the next 10 people to buy gumballs, 7 get yellow, 1 get red, and 2 get blue. Why are they asking us to explain this? Well, it's very easy. The gumballs might not have been evenly distributed in the gumball machine. A great number of red and blue gumballs might have been near the bottom of the machine, and now that they have been purchased, there are more yellow gumballs near the bottom, right? So that's one possible answer. Well, that's all of our homework, and I hope that cleared up using probability or models of probability. So I'll go ahead and see you on the next lesson. Have a great night.